What is a neural network?
Sure. A neural network is a set of connected neurons that process data similarly to the human brain. Each neuron performs weighted computations and activation. It's the building block of deep learning. Example: recognizing handwritten digits, 0 to 9, from image pixels in the MNIST dataset.
What are weights and biases in neural networks?
Weights control how much influence each input has on the neuron's output, while bias shifts activation. They're learned during training to minimize error. Proper initialization affects model convergence. Example: in image classification, weights decide which pixels are most important for identifying cat versus dog.
What is forward propagation?
Forward propagation passes input data through network layers to get an output. Each layer transforms data using weights and activation functions. It's the prediction phase before error calculation. Example: feeding an image into a CNN that outputs cat as the predicted label.
What is vanishing gradient problem?
It occurs when gradients shrink too small during backpropagation in deep networks. Learning slows down or stops for earlier layers. Can be fixed with ReLU, batch normalization, or residual connections. Example: a deep RNN failing to remember words from earlier in a long sentence.
What is batch normalization?
Batch normalization scales and centers data within a layer. It stabilizes training and allows higher learning rates. Reduces internal covariate shift. Example: using batch normalization in CNNs to speed up convergence while classifying images.
What is gradient clipping?
Gradient clipping restricts large gradients to prevent exploding gradients. Common in RNN training. Keeps model stable during training. Example: limiting gradient values while training an LSTM on long text sequences.
What is an autoencoder?
Autoencoders learn compressed data representations and reconstruct original input. They have encoder and decoder parts. Useful for dimensionality reduction and anomaly detection. Example: detecting unusual credit card transactions by comparing reconstructed outputs.
What are loss functions?
Loss functions measure how far predictions are from actual results. Examples include MSE, cross-entropy, and MAE. It guides optimization through backpropagation. Example: using cross-entropy loss when classifying handwritten digits.
Well, I'm happy to say you were selected. Congratulations.
Thank you, sir. Thanks to ZoomInData for their real-time projects, mentorship, and constant support. I feel like my career has finally started the right way.